Hello everyone. Our last question on the August Regents, number 37. We're going to take a look at a system of inequalities question. We're first going to have to write the system. You can see why this is a part 4. So we have to create a system, we have to graph it, and then there's a little analyzing question on the bottom. So 3 different parts here. So let's start with writing it. This deals with Edith babysitting. She babysits X hours a week. That pays $4 an hour, and another job as a library assistant, $8 an hour for Y hours a week. She will work both jobs. She can work no more than 15 hours a week. So right away we see our inequality. If X and Y are both the number of hours she has at some job, this is going to be like our total equation. X plus Y, the number of hours from job 1 plus the number of hours from job 2, no more than 15 hours a week, meaning she can work 15, but she can't go a minute over that, so less than or equal to 15. You wouldn't want to just say less than 15, because the way that's phrased, technically it could be 15. Okay. Now, the second part is going to be in our last sentence here. Edith wants to earn at least $80 a week. So we see another inequality vocab term. And with this one, at least, we know at least is greater than or equal to. So she really wants more than $80, but she'll take 80 bucks. Since this is a money equation, we want to incorporate how much she's making at each job. So at the babysitting job, which was X hours, she makes $4 an hour, so my coefficient's 4. At the other job, she makes $8 an hour, so coefficient's Y. So that's my system. So part 1 is done in this question. And now we're going to graph this. And I like to graph these using intercepts. It makes it a little bit easier instead of having to get them in Y equals and plot some slopes. Sometimes these work out a little weird, especially with the scales. If we take a look at the graph we're given, sometimes it can come out a little, it can be a little difficult graphing in slope-intercept form. You have the option of doing that, particularly with these system of inequalities. The the intercepts work out a little bit nicer, particularly because they're larger numbers too. So in red, our top equation we'll do first. The x-intercept, which is where y equals 0. If we basically pretend the y is not there, it's just going to say 15. It's going to say x is equal to 15. And very similarly, for the y-intercept, which is where x equals 0, pretend x isn't there. Cross out the x. It's going to say y is less than or equal to 15. So the y-intercept is at 15. So if we go over to our graph, we're going to plot 11, 12, 13, 14, 15. And 11, 12, 13, 14, 15. And while we're at it, we should label our axes here. So this was the number of hours she babysat, x. And this was the number of hours she was working at the library. Library assistant, library. I'm just going to abbreviate. And now we're going to connect those with a line. It is a solid line, so we don't have to do a dashed dotted line here. And in terms of shading, I don't want to shade just yet because I'm only going to shade the solution region. But since it's saying less than, it would be shaded below. I'm just going to make a few markings. So when I graph the other line, I know kind of where my second pair should be, second shading should be. Now the intercepts for the second graph. And again, opposite coordinate is 0. For the x-intercept, if I pretend y is not there, cross out the y component of this, it will say 4x and 80. So if I divide by 4, I'll get x equals 20. For the y-intercept, I'm going to pretend the x value isn't there, and it's going to say 8y 80, 8y and 80 on the other side. If I divide by 8, I'll get 10. Basically, this intercept component, you're just pretending the other variable isn't there and basically solving for that variable. I'm solving for x here. That's how I got 20. So like 4 times what is 80? For y, 8 times what is 80? You get 10. You can see how easy this is to graph. So what I'm going to do in green, y-intercept at 10, the x-intercept all the way at the end at 20. Once again, a solid line. We want to make sure, as always with the system, we want to label. So I'm going to label this green one, and I'll go back to the red one, plus 8y. And this one's going to be shaded above because it was greater than or equal to. And our red one was x plus y is less than or equal to 15. Okay, so if this one's shaded above the line, on top of the line, right, above, where are these two shadings going to overlap? One's going down, one's going up. So this would be shaded up here, this would be shaded down here. They're going to overlap in this little triangle, this little slice right here. And let me just double check. Doesn't tell us to label the solution region with an S, but we could do it anyway. So any point, I'll use both colors to signify that it's both shadings. The solution to the system, to the scenario, is any point in this region here. And maybe we'll put a large S in there to signify that. This is the solution region. So notice I have them labeled. I don't have to put arrows on them because it doesn't make sense to continue into negative hours for either scenario. So I'd stop right at the intercepts. Okay, and now let's scroll down. One last follow-up question here. State one combination of hours that will basically satisfy this, which was to satisfy the original scenario. And it's a good thing we labeled the solution region. Basically, we just have to pick out one value in here. So I wouldn't get too close to, the boundary line. Pick something nice in the center. So I'm going to go right here. So that would be 2 hours of babysitting and 11 hours at the library. And obviously there's not quite an infinite number of answers here, but of course more than just this one. 2 hours of babysitting, which was the x variable, x number of hours, and we said 11 at the library. And since this is a 6-point question, I always like to look over all the components. You really want to make sure you don't lose a silly point for like forgetting to label or something like that. So we clearly wrote the system of inequalities. We used x and y because they were given to us, so we didn't have to use any let statements. I showed my work for how I graphed. We could have graphed using slope-intercept form, but we used intercepts to help graph. I have solid lines correctly. I shaded correctly. Labeled my axes. We can label the scenario if we want to give like a title to our graph, I suppose. So Edith's jobs. Sounds good to me. Edith's salary or something like that, I guess. Edith's source of income. Anything like that. We're giving a title to the graph just in case we've labeled the axes sloppily. And we answered the question on the bottom. And like we said earlier, there's more than one answer here. So if you answered this and you put, I don't know, 112, that would also work. Like I said, I wouldn't cut it too close. I wouldn't want to say like a point right here, even though it might work, obviously, because it's on a solid line. Always play it safe. Pick a point nice and safe in the middle. Okay? Thank you for watching, and hopefully this helped you at number 37.